Good morning students. Welcome back to the new video lectures, and this will be the last video lectures on this chapter, that is chapter number 11. And in chapter number 11 we were discussing about work and energies. Okay, and after a long gap we are studying these video lectures because of the because of the time conditions, and we have been dealing with another activities and all. So because of this I'm sharing this another video lectures without a 1 week gap. Okay, so in this video lectures we have only two topics that we are going to discuss. The first one is law of conservation of energy. We have discussed how to derive the kinetic energy, potential energy also. But now today we have also learned that in the previous video lectures that whether the energy can be transformed, whether the energy can be convertibles or not, interconvertibles or not. Okay, yes, in energy can be interconvertibles. Okay, based on this only we will discuss this one, the topic, that is law of conservation of energy. Okay, law of conservation of energy give the same statement like law of conservation of mass. Okay, so law of conservation of energy, what is said? Law of conservation of energy. Energy can be neither be created nor be destroyed, but can be transformed from one from to another. Okay, energy can be neither be created nor be destroyed, but can be transformed from one from to another. Okay, so the problem is what do you see? Let me take an examples here. Okay, let us learn from these examples as I have drawn the diagrams. If I have given the object okay, in a certain height, I didn't let the object to move. I'm just holding the object at a height from the ground level at the height of h. This is your ground level, and from the ground level the object is at the height of h. Okay, so what will be the energy that the object will be? What will be the energy that the object will be performing? Okay, the object here is, do you think the kinetic energy will be, what will be the values of kinetic energy? Directly I'm questioning, what is the values of kinetic energies? What will be the values of kinetic energy for this object? Since the object is not moving, I have already told you kinetic energy is energy process due to the movements of the energy process due to the movements of an object. Okay, since the object is not moving, that means what? The kinetic energy, that means that if the object is not moving, when we talk about kinetic energy. Okay, if the object is not moving, we know the kinetic energy is equal to what? 1 by 2 mass into velocity. Since the object is not in a motion, that means your velocity is 0. Yes or no? Since the object is not motion, that means your velocity is 0. That means your kinetic energy will be equal to what? 1 by 2 mass into 0 square. That means your kinetic energy is totally equal to 0. Okay, your kinetic energy is directly equal to 0. Right? But what will be your potential energies? We know the potential energy. What is the potential energy now? What will be your potential energy? Your potential energy will be what? PE will be what? Is equal to mgh, because the object is still on the, it is movement, right? It is on the, what is it? It is in the some height. Okay, the object is not moving. That means they will possess a potential energy. Okay, so from here we have learned that, okay, your kinetic energy is whenever the object is in the at the height without movement, that means the object is potential energy, but there will be some potential energy, that is mgh. What will be the mass, and what will be the height, and what is the gravity? We know 9.81, right? So based on this we can get the potential energies. The kinetic energy is 0, potential energy is mgh. Okay, so now the moments I left the object, okay, the moments I left the object, I let this object to fall down. That means the object is now in the motion, right? Now the object is in the motion. That means what? Your kinetic energy, when the object falls, okay, your kinetic energy become what? 1 by 2 mv squared. Whereas your potential energy may become 0. Why? Because your height will decrease. Okay, height will decrease, that means your potential, that means your height will become 0 also, right? That means the object is moving, that means the height may become 0, that means the object is moving down, right? The height is decreasing down, that means your height will become 0, that means your potential become 0. At the very beginning, when the object is at the rest, they had a potential difference. a potential energy, but they have a kinetic energy seem to be zero. But after when I've let the object to fall down from the height, that means they gain a kinetic energy, instead they lose the potential energies. They lose the potential energy. At the very beginning, they have a potential energy, they don't have a kinetic energies. Okay, but when the moment the object let it to fall from some height, they gain a kinetic energy, but they lose the potential energies. Okay, so what does we learn from here? Okay, the kinetic energy does not create it ultimately. Okay, the kinetic energy does not create it automatically, but it get transformed from whom? The potential energy. It is transforming from the potential energies. Okay, it is getting transformed. Okay, the potential energy is converted into kinetic energy when the object start in the motions. Okay, so that means what? Whenever the object is at rest, they consist. Whenever the object is at rest, they consist of potential energy. But when the object is in a motion, that means they gain the kinetic energy. They start attaining the kinetic energy, and that kinetic energy they gain the kinetic energy from that potential energies only. Okay, from that they gain the kinetic energy from that potential energies. Okay, so that is what we are learning. That from here we have learned that the energy can be neither be created nor be destroyed, but it can be transformed from one form to another. Okay, it may be conformed from kinetic energy, it can be conformed to potential energy. Okay, then potential energy again will be converted to kinetic energy again. Okay, now you see, as I told you, the object is in some height. Okay, the moment it reaches the ground, that means object in the kinetic energy. Okay, so that is what we are learning, that from the potential energy it is converting into kinetic energies. Okay, so when the object is about to reach the ground, the h becomes 0, and the velocity will increase. Okay, velocity will increase. Okay, this is the kinetic energies would be largest, and the potential energy will come to 0. Okay, and the sums of the kinetic energy, their total sums. Okay, before and after the kinetic energy plus potential energy will remain constant. Before the object remain in the rest. Okay, before the object is at rest, object is holding. The moment it left, after the object let it to fall, then the kinetic energy plus potential energy, their values also will remain constant. Okay, so from here we have learned that energy we cannot create them. We cannot destroy them also. Whatever the energy that we are creating, okay, whatever the energy that we are getting, okay, it is transforming. Okay, from one from the energy from one from the another. Okay, so that is what we have learned, that the sum of the kinetic energies and potential energies always is equal to total mechanical energies. Okay, we can define that the free fall of the object, the decrease in the potential energy at any point. Okay, so we find that during the free fall of the object, decrease in the potential energy at some point and appear in equal amounts of the increase in kinetic energies. Okay, thus the continuous transformation of gravitational potential energy into kinetic energies. Okay, so from here you see, we'll give some examples also. Okay, now when you talk about the productions of the productions of electric currents. Okay, electric currents or electricities, or you say electric energies, or you can say electric energy, current you say, right? So here you see, at the very beginning, the water gets stopped here. So when you talk about the dam, it is very easy to understand from the dam. Okay, so this dam will let it fall, and when the object is the water is get stored here, that means the water remain potential energy, and because of this potential energies, again it let it fall from some height, then they gain a kinetic energy, and because of this kinetic energy, okay, this turbine which is here, it get rotate. Okay, and because of these rotations and this kinetic energy, they gain a rotational energies, or we also call as a mechanical energy. Okay, now this turbine is connected. This turbine, okay, this black turbine is connected with the generators. Okay, this generator and this mechanical. The moment they get mechanical energy, then they gain electrical energies. Okay, we are not creating any energy, but instead of this, we are transforming the energy again and again to get output energies. Okay, so all this energy, if I sum, it will be always a constant. Okay, so energy can neither be created nor be destroyed, but instead they will transform from one from to another. Okay, instead they will transform from one from to another. Okay, this is all about the law of conservation of energy. Law of conservation of energy is said that energy can neither be created nor be destroyed, but it can transform from one from to another. Okay, so this is all about the kinetic energies. Okay, last topic, that is what? The rate of doing works, that is power. Okay, let's talk about this power. Okay, power. We know powers. Okay, I have more power than you. You have more. You are less. Okay, what does the power? What does the power indicate you? What do you? How can you relate the powers? Can you give some examples? You see, the power means what? It is the rate of doing works. Okay, rate of doing works. Let's not discuss about this in the terms of scientific. Let's try to understand this in a normal way. Okay, now if I let you to push this object, which is of 5 kg, and another one which is of 10 kg or 5 kg. Okay, same thing. Now this one is pushed by a person. Okay, by a person, and here is it is also pushed by another person. But this one is an old boy, old man, and this one is a young man, young boy. Okay, very young. Whom do you think will be having more power? Okay, if the object, these boys have moved the object for the distance up to, like, let's say 5 kilometers in 1 hour. Okay, he have led the object 5 kg, 5 kilometers, but this object, okay, have moved the same distance, but he have moved the object in 5 kilometers in 30 minutes. Who have done the less? Who have done the more, like in the usual works? He have completed in the 30 minutes. He have covered 5 kilometers, but this boy, this Dolman, have covered 5 kilometers in 1 work. Who have done more works, as per your opinion? This boy is doing more work, because after 1 hour he will be covering another 5 kilometers, right? That means total it become 10 kilometers in 1 hour. Okay, that means his power is less as compared to his powers. Okay, so power is small. What we talk about the powers is what? It is power is the comparisons. Okay, the work done in that particular unit is what we call as a power. Okay, work done is what? Power is what? Power is equal to work done. Okay, work done in that time. Okay, we are measuring with respect to time. Okay, work done in respect to time is what we call as a power. That is why the word is called rate. I have told you in the class also that rate, whenever the rate comes, it is always a quantity, that is time. Okay, it is always a comparison with the time. Okay, rate of velocity. Rate of velocity means what? Velocity divided by time, that is your acceleration. Rate of displacement, that is what? Displacement divided by time, that is your velocities, right? So whenever the rate comes, we have already told you in the class, whenever the rate comes, that means it is a time. Okay, so rate of doing work means work divided by time is what we call as a power. Okay, so rate divided by work divided by power is called as a work divided by time is called as a work divided by time is called as a power. Okay, how much work? Okay, how much work can be completed in that particular second? Okay, in 1 second. That means he has more power. That means you see the power is equal to W by T. That means what? A power is directly proportional to the work done, and a power is what? Inversely proportional to the time. That is what? Inversely proportional to the time. That means what? If you take more time to complete works, okay, you are considering more time to complete work. You are taking more time to complete work. Okay, more time to complete work means what? You have a less power. Okay, if you are taking more time to complete work, that means you have a less power. But if you are taking less time to complete that particular works, that means you have a more power. Okay, so what does it mean? If the time is increasing, then its power will decrease. But if the time is decreasing, then its power will increase. Okay, so if more time you are consuming, if more times you are consuming to do some work, that means you have a less power. Okay, and the same works you are taking less time, that means you have more power. Okay, so you have to remember, if more time means less power, less time that means more power. Okay, so that means what? If I let you to holes, okay, if I let you to holes, as I told you, okay, if I let you to move from this to this, basketfuls of waters, bucket full of water, not basket full of waters. Okay, a bucket full of water, you are asked to move from this place to that. Okay, now that boy, you are taking 5 minutes to reach these corners. Okay, and the same bucket, I'm letting it to move to another boy which is younger than you. He is taking what? At least he will take 10 minutes to reach these corners. As you know, that means you have more power. You have more power because you are taking less time. But he has less power because he is taking more time. Okay, so that is what I say. If more time you're consuming, that means you have a less power. If less time you're consuming, that means you have a more power. Okay, so what is the rate? Power. A power is the rate of doing work. A power is the rate of doing work. And this power, the power is mostly, the SI unit of power is what? It is a watt. Okay, it is a watt. Or SI unit of power, standard unit of power is what? SI unit of powers. SI unit of powers is always a watt. It is given, okay, in respects of James Watts. Okay, in honors of a James Watt, the unit of power is always watt, or we also sometimes call as a joule per second. Okay, joule per second. Okay, so 1 joules of powers. Okay, 1 joules of power, or 1 watt of power, 1 watt of powers. Okay, 1 watt of power is defined. What is the 1 watt of powers? Okay, 1 watt of power is defined as the rate of doing works. Okay, rate of consuming the energy in 1 second. Okay, rate of doing works in 1 second. That means what? One work is defined. Power is defined. Okay, the work 1 joule per second. Okay, that means work done. Okay, work done. 1 joules of work done. 1 joules of work done in 1 second is known as a 1 watt of the power. That means what? 1 watt is equal to what? 1 joule by 1 second, or we can say 1 joule per second. Okay, so the work done, okay, the work is completed, the completed work is 1 joules in 1 second. In 1 second you're completing 1 joules of work. Okay, in 1 second you're completing 1 joules of work, then we say 1 watt of the power. Okay, 1 watt of the power. So work done is 1 watt of the power is what? 1 joules of the work done is the work done in 1 second. So, okay, work done is 1 joule in 1 second. That is what we call as a power. Or you can also say, okay, a rate of consumptions of energy, a rate of consumptions of energy in rate of consumptions of energy in 1 joule per second is what we also call as a 1 watt of powers. Okay, so this is a standard unit, but mostly standard unit of the power is mostly defined in kilojoule. Okay, it is defined in always kilowatt. Kilowatt. Okay, so 1 kilowatt is always equal to 1 watt, 1000 watt. 1 kilowatt is always equal to 1000 watt. Remember this one. 1 kilowatt is always equal to 1000 watt. Okay, 1 kilowatt is always equal to 1000 watt, and 1 kilowatt, okay, kW is always equal to 1 kilowatt is always equal to 1000 joule per second. Okay, 1000 joule per second. Okay, 1 kilowatt is also equal to 1000 joule per second. Okay, so power agent may be varying with the times. Okay, this means that agents may be doing works, okay, at a different rate at different intervals of time. Therefore, the concept of power is useful. So we have to understand the average power by dividing the total energy consumption by the total time taken. That means what? We have to understand the total concept of the power. So we can also the total concept of the power is what? We can also the total powers. Okay, total powers is always is equal to total energy. Okay, total energy consumption. Total energy consumption divided by total time taken. Total time taken. Okay, total energy is equal to what? Total energy is equal to total powers is equal to what? Total power is equal to total energy consumption by total time taken, or total work done divided by time taken. Okay, so this is what we call as the average of the powers. Okay, the average of the power is what? Total energy consumption by the total time taken. Okay. Now let's talk about this commercial units of energy. You see, when you talk about the commercial units, okay, the joule per second, okay, a joule is very small or inconvenience for a very large express. Like when you talk, you might have heard about joule per second, or you might have heard about it commercially. Okay, when commercial means business. Okay, when you talk about in a business or the power in your homes. Okay, so it is very small to measure in terms of joule. Okay, in terms of joule. Okay, so it is very like energies SI unit of energies are usually very small to measure in terms of joule. Okay, so in order to measure in terms of in a large quantities. Okay, so energies are mostly called as the bigger unit of energies are called as commonly. Okay, energy, we know what is it? Energy is the capacity of doing some work. Okay, and usually energy SI unit is what? It is the joules. Okay, so SI unit of energy, the joule is very small unit, and it's very inconvenient to use in the commercials. It is very inconvenient to use in a large quantity. So this is energies are mostly expressed in 1 kilowatt hours. Okay, 1 kilowatt hours, and 1 kilowatt hours is equal to what? 1 kilowatt into 1 hours. Okay, so if I want to convert this in the form of joule, so what shall I do? What if I want to convert in this form of joule? What shall I do? 1 kilowatt is equal to what? 1000 watt into 1 hour is equal to 3600 seconds. Or you can write S. Now we also know that what is it? 1000 watt. 1000 watt. We also know 1000 watt is equal to what? Joule per second into 3600 seconds. S and S cancel. Now multiply this 3600,000 joule. That means what? 3.6 into 10 to the power 1, 2, 3, 4, 5, 6, 10 to the power 6 joule. So 1 kilowatt is equal to what? 1 kilowatt is always equal to what? This much joules of second. Okay, so this is your 1 kilowatt is 3.6. Okay, 1 kilowatt of 1 kilowatt kh is equal to 3.6 into 10 to the power 6 joules. Okay, so this is what we usually discuss in your powers of energies. Okay, energy in terms of commercial whenever we are selling or whenever we are doing some business. So we mostly measure in terms of kWh. Okay, so energies like you use in the households or industries or commercial surplus are usually expressed in this way only. That is kilowatt hours. Okay, for example, electric energy consumed during the 1 month is in and when you talk about that when the energy consumes in a 1 month, okay, it's mostly defined in units. Okay, it's mostly defined again in unit. That is not. So when you talk about what is it? It is mostly defined in unit again. That means what? 1 unit is always equal to. That means energy consumed in 1 month. The electrical energy consumed in 1 month is also the same thing only. That is what? 1 unit that is equal to 1 kilowatt hours. Okay, so 1 kilowatt is in a commercially we discuss in kilowatt. So in 1 month you are consuming the energy. Okay, that is mostly expressed in terms of unit. That means unit is equal to 1 unit is equal to 1 kilowatt per kilowatt hours. Okay, so this is all about the chapters. This is all we are discussing about the rate of work and energies. Okay, so I believe that I have covered all the chapters. I believe that I have covered all the topic. But any problem is there, you can either come and discuss directly with me also. Okay, if you have any problems in numerical problems or numerical point to discuss or clarification is needed, you can come and discuss with me. Okay, so might be like some topic maybe miss out, some point maybe miss out. Okay, so please as much as possible try to make a clarification by yourself, and this way we can learn and we will learn more about it. Okay, so I want all of you to go through the chapters. I want all of you to go through and study very well. Okay, and we'll meet in the next videos in the next very chapters. Okay, after the examinations. Okay, and anyway, stay safe and study hard. Okay, bye bye.